Hey everyone, welcome back. So today we're going to be solving Leetcode 144 binary tree preorder traversal. So for the most of you, this might seem like a very easy problem because this is the basic traversal of binary tree DFS. But the reason that I'm making a video on this problem is because this one requires a very good understanding of recursion of like function programming, and that is the reason I'm making a video on this, so that we can actually understand what is happening inside each and every function call, right? This might seem easy when you code it. It's just few lines of code. It's not that hard, but when you actually trace the call stack, or trace the function calls, you will understand how the traversal, how DFS is working behind the scenes, and how we are actually getting the output. And when you understand that, your binary trees would be very easy. Any problems in binary trees, you can easily solve it because you're understanding what's happening in every call, right? That's the reason I'm making on this video. And in this video, what I'm going to be doing is I'm going to be taking an example, and I'm going to be tracing the call for that, and then we're going to be tracing the call with stack, and then we will print out the output, and then we'll code the same. Okay. Here we have to return a list of integers. That's okay. We'll just give the return type of list of integers, and we'll keep adding it. But for the understanding purpose, I will just print the nodes as we go through the call stack. Okay. So let me take an example. Okay. So this is the example that I've taken, and if you see, each node has a value and the address assigned to it. So I've just assumed the address to be 5k, 12k, 10k, just as a value of the node. This is just for the understanding purpose, and with this is what will be tracing the entire preorder traversal. Okay, so just the basics on nodes, just the basics on how the node looks like for a tree. You have it divided into three parts actually. You have something called as the value. Okay, this can be anything. In this case, it's an integer, but it can be anything. And then you have left, which is again a node, and then right, which is again a node. Okay, left and right are both of type nodes, or tree node, whatever. Okay, and if you look into the class of a tree node, it looks something like this. Okay, you have something called as int value, again value, and you have something called as node left, and then node right. Okay, this is how your this is how your class on a high level looks like. Okay, so node left holds the reference of the node which is towards the left, and node right is something that holds the reference towards the right. Okay, and yeah, so these are the basics. So now let's get started. Okay, let me draw a stack. Perfect. So forget about this question for a while. We are going to be printing each and every node, okay, through preorder traversal, instead of returning it as a list, because returning, we can just give the return type as a list instead of void, and then just return it. Okay, so for understanding, we are going to be printing these values. Okay, so now how does a preorder traversal actually look like? Okay, let me write the function, and with that we'll trace it so that you get the understanding. Okay, so let's call the function as a void, since we're going to be printing, and then let me call it preorder recursion. Okay, so this will have something called as node of root. Okay, and you'll have to print preorder, right? Okay, now before that, what is preorder traversal? Preorder, how does it actually look like? Preorder traversal is nothing but you'll be first going through the node, okay, then to the left node, then to the right node. Your node is your node, and left is your left node, and right is your right node. So you'll be traversing through the entire tree using this particular direction. Okay, For post order, it will be LRN, where you'll be going to the node in the end. First, you'll be going to the left, and then in the in order, you'll have L and R. So you'll be going to the left, then the node, and then the right. But in pre-order, you'll be going through the node, left, and then the right. Okay. So this is exactly what we'll be doing over here as well. So what we'll be doing is we're going to be printing sopln system.print line of root dot value. Okay, root dot value. Okay, and then we have to go towards the right. So what we'll be doing is we'll make a recursive call, recursion of root dot left. Okay, and then another call for going towards the right. Okay, don't worry, you will understand as we go through the stack tricks. But yeah, now you'll be going towards the root dot right. Simple. Okay, now if you know, every recursive call, every recursion that we write, every recursive function that we write needs to have a base case, right? Since there's not a loop, there's a functional call every time. Your stack needs to break at some point. What is that point? If root equals to null, then what I'm going to do is I'm just going to return. Okay, hold on, if you didn't understand what this means, I'll explain it to you. But this is your break case. Okay, perfect. Okay, now whenever you're writing a class for the tree node, you'll be writing it as something like this, right? Tree node, you'll be writing it as something like this. You'll have you'll have int value. Okay, and then you will have node of left. Okay, and then node of right. Okay, this here, this thing. Okay, now let's say that you have a constructor. Okay, tree node, whenever you're creating an object of type tree node, you'll be calling a constructor with something called as a value. Okay, this, forget about the variable type, this can be anything, but I'm just assuming it to be integer. Okay, when you're doing this, when you're constructing the constructor, you'll be giving this dot value, that is this dot this value equals to value. Okay, now what about node left and right? Right, we cannot give an address, we cannot give a reference. So ideally, initially, your left, your this dot left will be set to null, and also your this dot right will also be set to null. That is exactly what I mean by if root equals to null, you'll return. Right, at some point your left node, right, will be null, or at some point your right node will be null. In that case, we don't have to keep traversing further. Okay, we'll just have to return. That's exactly what I've written over here. Okay, you'll better understand it when I trace the function calls, but yeah, these are the basics. Now let's get into the function call. Okay, if you see, what is a recursive function doing? It's doing three things. There are three steps: step 1, step 2, and step 3. Okay, and I'm exactly going to name it. Okay, the same. I'm going to name it as step 1, step 2, step 3, and I'm going to be using these steps, and I'm going to be going through each of these steps one by one. Okay, now let's give a parent call. Parent call will come from your main function, which should be calling preorder of let me write rec instead of recursion. I'm going to be calling root node root. Okay, this is nothing but my parent call. Okay, I mean, whenever you're calling another function in a programming, whenever you're calling another function while programming, of course, that call will be in the stack, right? And that's exactly this call. That's a parent call. Okay. Okay. Now let's go through it one by one. Okay, let's follow these steps. and then let's go through the call trees one by one. Okay, it's very interesting. Please focus on this so that you get the complete understanding of how recursion is working. Okay, now the first call, when you send node root, what happens? It comes down here. Okay, it checks is root equals to null. Is root equals to null? No, it has a value of 5. It has a value of 5 over here. It's not equal to null. So what I'll do, I'll go down. So I'll go down and let me actually write this call over here. Preorder of 5k. Okay, there are 3 steps. That is, these 3 steps is what I mentioned over here. Okay, there are 3 steps. Okay, now what happens is, where do I print the output? Yeah, but I'm gonna be printing the output over here. Okay, there are 3 steps. The first step is nothing but you're printing the root dot value. Your root dot value is nothing but 5, so you're printing 5. Your step 1 is over. Okay, now what is your step 2? Your step 2 is nothing but preorder of root dot left. So what you're doing is you're making another recursive call. So a call now a call comes into the stack free with preorder of root dot left. What is 5k dot left? 12k. Okay, now this also will have 3 steps. Okay, now what will happen is, again it'll come down. Your SOPLN is root dot value, which will print the value, that is 12. Now this will also have 3 steps. The first step is over. Okay, now what will happen is, the first step is over. Then it'll call another recursive call of preorder of recursion of root dot left. So we will be calling root dot left. That'll be preorder of root dot left is 12k dot left, which is nothing but 6k. Okay, this will also have 1 2 3. Okay, now again what I'm doing is I'm printing my root dot value. So I'm printing 6. Okay, now after this, what am I doing? I'm making a call for root dot left. When you're at 6k, when you're at the node 6k, how will your node look like? It looks something like this. You have 6 over here. Wait, how will it look? You'll have 6 over here. That is nothing but the value. And do you see any node to the left? Do we see any node towards the left? No, right? There's no node towards the left, right? So your left node will be nothing but null, right? But there is something towards the right. That is 22k. So this will be pointing to 22k. This is how your node will look like, ideally, right? Now this is exactly what we're going to be doing. Now for 6k, your first operation is done. What we're going to be doing is we're going to be calling preorder of null. Now what happens is our base condition is reached. So we've reached null. So what we're going to do is we're simply going to return, meaning that this stack will get this particular frame will get evicted out of the stack. Right? Makes sense. Now you come to 6k. Now when we come to 6k, a call was made from here, and then it goes up and then it came here. Now this happens to be null, so we'll return back to this particular call. After this particular call happens, this function is done. Right? Next we'll go to this function. So what will happen is step 2 is done. Right? Now we'll go to step 3. What is step 3? It will call preorder of 22k. Okay, preorder of 22k. Now this is a vector stack. I'll remove it, but just hold on. So this also have 3 steps. Right? Now, do we see any nodes to the left or nodes to the right? No, right? There are no nodes towards the left or right. So both will be null. When I call left, it'll be preorder of null. Preorder of null. Okay. So when null happens, what will happen is this get evicted as stack. Okay, wait, I missed something. So when I came to preorder of 22k, I forgot to go through step 1. I directly went to step 2. I have to print 22k, right? I have to print 22. So now I'm printing 22. right? Now first step is done. Now second step, what happens is it calls pre-order of null, it returns back. Second step is also done. Now it goes to the third step, that is nothing but pre-order of null again, because there is no right node as well. So this will also get evicted out of the stack. Now it will return back, this one will go out. Third step is done. Now third step is done, so this will also get evicted out of the stack. Now if all the steps are done, that function will get evicted out of the stack because it doesn't make sense to keep it in the stack, right? So we'll come back to the element that is on top of the stack. Okay, so let me just erase all this since it's all evicted out. Okay, now what happens is for 6k we went through operation 2, which was null. Okay, now we went to operation 3, we printed out. Now third operation is over, this will also get evicted out of the stack, right? Now for 12k, 6k is done, that is this operation is done, this operation is done, so I'll mark it as done. Second operation is done. Okay, now I'll evict this out of the stack. Okay, now what will happen? For 12k I have to call the write, right? Because the second operation is done, the third operation is pre-order recursion root or write. So what will I do? I'll call pre-order of what's on right, null. I don't see anything towards the right, so I'll call it as null. Now what will happen is this will get evicted out of the stack, then it'll come down. Now my third operation is also done. Perfect. Now this will get evicted out of the stack. Okay, now my third operation is done. After this third operation is done, this will also get evicted out of my stack, right? So I'll evict this. Perfect. Now what will happen is for 5k your first operation got over, now your second operation also got over. Okay, now remaining is the third operation. So what will I do? I will have to call the third operation, pre-order of write. Pre-order of write is nothing but pre-order of 10k. Okay, this will again have step 1 2 3. I'll print 10. Okay, I'll print 10. Now step 1 is over. Now I'll call step 2, that is pre-order of, what is step 2? Root dot left, right, of 3k. This will also have step 1 2 3. I'm going to pen 3. Step 1 is over. Now I'm going to go to step 2, that's nothing but pre-order of step 2 was 15k. This will again have 1 2 3. I'm going to be printing 15. First step is over. I'm going to be calling the second step, that is pre-order of order of what is it, null, because there is no element towards the left or right, right? So pre-order of null will take place. Okay, now what will happen is this will get evicted out of the stack. My second step is done. Now again I'll make a call for the root dot write, which is again null, as I mentioned it over here. So I'm going to be marking this also as null. Okay, so this will also get evicted out of the stack, and then it'll come finally to this point. At this point what will happen is third step is also over, so this will also get evicted out of the stack. Okay, when this gets evicted out of the stack, it'll come back to this for this second part is over. Okay, so I'm going to be erasing this. Second part is over. Okay, this is exactly how your stack functions, right? This is exactly how, whenever we're erasing something, whenever we're adding something, this is exactly in the backend how your stack is functioning. Okay, now second operation is over. It is gonna call the third operation, which is nothing but pre-order of root dot write. So I'm gonna be calling pre-order of root dot write. What is 3k dot write? It's 4k. Okay, this is gonna be having 1 2 3. I'm gonna be printing 4. First operation is over. Next, I'm gonna be calling root dot left for 4, root dot right for 4, which is again null. Right, so pre-order of null is going to be called, I'm just going to write it as n. Okay, so this is going to get evicted from the stack. Then the second operation is over. Then I'm going to be calling pre-order of n again, null, because the root dot write is also null, right? So what will happen is this will also get evicted out of the stack. My third operation is done. Now this will also get evicted out of the stack. Okay. Now what happens is it'll come back to this root dot write root dot let me yeah root dot write. This is 3k. Root dot write for 3k is also done, right? We have traversed through that. Now what happens is the third operation for this is also done. Now this will also get evicted out of the stack. Okay. For 10, what is the second operation? For 10, what is the second operation? It was 2. That is nothing but your root dot left. Now have we considered all the elements on the left side? Yes, we have. We have considered 10, 3, 15, 4. 10, 3, 15, 4. Yes. So now my second operation is also done. Right? So this will also get evicted out of the stack. Perfect. Now I'm going to take this all out. Okay. Perfect. Now what is left? My third operation for this is left. Oh wait. Sorry. This is done, but this one get evicted out of the stack because I still have third operation remaining for which one? Root 10k. Root 10k. I still have third operation remaining, so this will not get evicted out of the stack. Okay. So now what will happen is I will remove this. Okay. Now we're going to consider the elements to the right. So what will happen is preorder of 10k will preorder of 19k will take place because that is the element towards the left. Right, that is the element towards the left. Perfect. Now this will have 3 operations. The first one is to print, then this will go away. The second one is preorder of left. As you see, preorder of left is nothing but null, so I'm going to be calling null. So this will come down. What will happen, this will return this thing. This will get evicted out of the stack. My second operation is done. Okay. Now I'm going to be calling the third operation. This is nothing but preorder of 17k. Right? This is going to have 1, 2, 3. Okay. As you can see, left is also null, right is also null. But the first operation is to print, that is 7. The first operation is over. Okay. Then I'm going to be going towards the left. Preorder of left is nothing but null. Right? So what is going to happen is this is going to get evicted out of the stack. Now my second operation is over. Now I'm going to be calling preorder of right. Nothing but null again because the right is also null for 17k. So what's going to happen is this will also get evicted out of the stack. Then I'll come down over here. This thing is also over. Right? 3 operations over. So what will I do? I'll evict this also out of the stack. Right? Now I come back to 19k. Let's see if I've considered all the elements towards the right of 19k. Right? Yes, I've considered all the elements towards the right. It becomes 19 and 17. Okay. Now what will happen is this also third operation is over. Okay. Now this will also get evicted out of the stack. Now I'll come to 10k. Let's see. The third operation is what I just performed. Let's see if I've considered all the elements on the right hand side of 10k. If you see 10, 19 and 17 are the elements on the right hand side. 10, 19 and 17 I've considered. Perfect. So my third operation is also over. This will also get evicted out of this. Third operation is over. This will also get evicted out of the stack. Right? Makes sense. Now what happens is I'll come to preorder of 5k. Now the third operation is what we performed. We went to 10k, then we went to 10k first, then we went to 3k, then we went to 15k, then we went 4k, then 19k, then 17k. All these operations are done. We have considered all these elements. Now what will happen is third operation is done for 15. Now this will also get evicted out of the stack. Okay. So let me remove all this. Perfect. Yes. Now perfect. Okay. Now the parent call. Since there's a void call, what happens is your recursive call gets executed. Once all its operations are done, as we can see over here, all the operations over here are done, right? Then what happens is it comes back to this. Now this also will get evicted, right? Now let's remove this. Now your stack is empty, which is what is expected. Now your stack is empty. Perfect. Let's see if this is our output. Okay, let's go through it. What are you doing in preorder? You're going through the elements N, L, R. So first you're going to be taking 15, 5. Then you're going to be left side. Here you'll be considering 12. Left side of 12. Then you're going to be considering 6. Left side of 6 is null. So let me mark it as null. Then let me mark it as null. Then what are you going to be doing? You're going to be going towards the right, which is nothing but 22, right? Because it's NLR. Okay. Now for right, you're going to be going towards the left, which is again null. Then you're going towards the right, which is also null, right? So all of this is done. So you're going to be coming towards the top 5, right? Then you're going to go towards the right, because N is done, L is done for 5. N is what 5 is, L is what we have covered over here, and we're going to be going towards the right now. Okay, so right is nothing but 10 again, so we're going to be printing 10. We're going to go to the left of that 3, we're going to be printing 3. Then we're going to go to the left of that, we're going to be printing 15. Then we're going to be printing null and null, as these two values are null. Then we're going to be let me take this out. Yeah. Okay. So you have 50. You're going to be going to null and null, null and null, and then you have to go towards the right, which is nothing but 4. Perfect. Then what you'll do is you'll have to go towards the you'll come back to 10. Now you'll have to go towards the right of 10. The right of 10. So what you'll do is you'll go to 19, which will be your root node. You'll print 19. To the left of that, this will be nothing but null. Then what you'll have to do is go towards the right. So nothing but 17. After that, you'll come back to this one. So N is covered, L is covered, R is also covered. Okay, so your final output will be 5, 12, 6, 22, 10, 3, 15, 4, 19, 17. Let's validate with our output that we got over here. 5, 12, 6, 22, 10, 3, 15, 4, 19, 17. Perfect. Okay, I hope you got a very clear understanding of how the stack trace is working, how the stack is actually functioning in the backend whenever you make a function call, which is very, very, very important for any recursive problem. And since tree is completely based on recursion, at least DFS, we need to understand what's happening behind the scene, so that we can try out any problem and we can write any logic in our recursive call. Okay, so let's write the code for this now. The code is going to be pretty straightforward. So all we're going to be doing is we're going to be let's write the recursive function first. Okay, so this will be public, and it's going to return list of integers. Okay, this is nothing but let me call it as recursion only. Okay, and this is going to be taking tree node, and this is going to be root, and then I'm going to have list of integers. I'm going to call it final array. Okay, let's write the base condition first. If sorry, this is the base case. Okay, if my root equals to null, then what I'll do is I'll return final array. Perfect, that's a base case. Now what we're going to be doing, we're going to be adding the node to the final array. Final array dot add of root dot value. So this is how, okay, we have to write value. Perfect. Now what we're going to be doing is we're going to be calling recursion of root dot left comma final array, and then finally we're going to be returning, since this is our last call, we'll have to return this. We'll have to write root dot right comma final array. Perfect. So we are adding, and then we're calling the recursive function for the left, and then we're calling the recursive function for the right. Perfect. Here let's create a list of integer, call it final list equals to new array list. Okay, so what we're going to be doing is we're going to be calling the recursive call with root, okay, and then our final list. Okay, so of course this we have to return because the return type is list of integers. So we have, there are three operations. The first operation is, in our case it is printing, but in this case it's adding. Second operation is go towards the left. Third operation is go towards the right. Okay, so let's try running it and let's see how it runs. Perfect. Perfect. Let's look into the time complexity for this. It's often, right? Because you're just going through the entire tree node, and then you're going to the left value or the right value, which is in tree node itself. Okay. I hope you understood the solution. I hope you understood the stack trace. I would suggest you to go through this on your own and try doing this on your own so that you get a better understanding. Okay. One thing is, it's not always about solving a question. It's about understanding how the question works in the background. And this is a very, very good example of that. Okay. Thank you.